Yep. Thank you for the warm introduction, Jim, and happy to be here today. Get the screen shared here. Yeah, so I want to give you an idea of what we're getting into today. We're introducing a technology called OpenRewrite, like Jim mentioned. And the goal of this technology is automatic modernization of source code. So a pretty new discipline in the DevOps or DevSecOps realm here. We're talking about automated source-to-source transformation, automated refactoring. And this is based on a technology called OpenRewrite. It's got, and there's a product alongside of it called Moderne, which helps distribute those recipes, those rewrite recipes at scale on up to 300-400 million lines of enterprise code. So the kinds of things that we're really after here are these big, tedious lifts. Think like Java 8 to 11, Spring Boot 1 to 2, J8 and 4 to 5, heavy Java focus right now, but also imagine infrastructure as code. So Kubernetes, Terraform upgrades or patches, YAML transformation. In general, there's when we encounter infrastructure as code written in YAML, it tends to be this copy paste drift sort of feeling. And as we kind of proceed forward over the next several months, you'll see OpenRewrite expand into other languages. So right now we have plans throughout the remainder of this year to expand into just about done with COBOL, believe it or not, and TypeScript, Python, and C# are up next. These kind of lifts have always been something that we've been doing by hand, been very, very tedious. This technology originated back in 2016. I was working at Netflix on the engineering tools team, and really Netflix had this particular culture called freedom and responsibility that they're famous for, which is essentially that no central team, no platform team can impose any constraints on what product engineers do. So unlike a lot of organizations where there's at least some central control or the ability to gate the delivery of software, at Netflix we couldn't impose gates. So as a central team, if we wanted to say move from at the time Java 6 to 7 or 7 to 8, or we wanted to patch a particular vulnerability, or we wanted to eliminate the use of some API, it was very difficult. There was two of us working on engineering tools. There were 700 engineers that we were servicing at the time. And we spent a lot of time on reporting technologies, on things that would go and identify problems in the code and report them to teams. And we tried all sorts of ways of making it more palatable, making it beautiful, making it servicing it where developers work. We even went so far one hack day to build an automatic video, which is if you made a breaking API change, it would go work out the whole dependency hierarchy and determine what teams you're going to break, and it would automatically create this video that would flash the pictures of individual team members on the team you're going to break, and it's here's who you hurt today, and it's Sarah McLachlan music in the background, and we'd email these things out. So we tried kind of everything in terms of reporting, in terms of how to get people to move, and it just didn't work. Because I think the thing is, when it comes to big transformations like this, though they're important to the organization as a whole, on any given day, engineers have to do, they have to do feature work. They have to do, critical business work. And this stuff just kind of falls behind. It always gets negotiated off of the roadmap, it feels like, to the point where you really, really fall behind. So we would ask folks, what would it take for you to actually move forward? And we kept hearing the same answer. If you do it for me, I'm happy to accept the change. But if otherwise, I got other things to do. So at some point, that's where the really genesis of OpenRewrite is take that literally. Let's do it for them. So in the few years that's kind of transpired since then, I think what we've noticed is, as an industry as a whole, this software industrial revolution has really arrived. We've got more and more software. We got more and more code really in our organizations, and I think it's really because code used to be written kind of from the ground up, more or less proprietary. And these days, like, software is 20% custom glue code, stitching together 80% OSS software that forms the building blocks of the experiences that we build, and that's great. I love that. It means we ship products really quickly. We ship a lot of them, but the maintenance activity has actually grown. So here, this is actually a hidden infographic. We have a partner we work with that in 2014 had 40 repositories, just a small company. Today they have 900. And back in 2014 they had 70 engineers. Today they have 70 engineers, and I think it's that level of volume growth, about 25 times, that we've seen in a lot of places. So it's like this, what used to be a cottage industry is now this almost like assembly line industrial process of developing software. And we need different ways, I think, of really getting after the maintenance activities. The good thing about us all really depending on the same open source substrate, we're all using Spring Boot or Kubernetes, or we're using GitHub Actions, or we're using these sort of common base building blocks, is that if once you could write a recipe to make a transformation, to fix one of these things, it's highly repeatable from organization to organization. And so it applies to Sabre, it applies to this, a large bank, it applies to the tiny insurer, and it applies to Netflix. It kind of doesn't matter what the industry is, what the size of company is. We all really build on the same substrate. The world's code base is really connected by this open source substrate, I think. So what the goal of OpenRewrite is really, if we're going to automate change and we're going to do source to source transformation, and we're expecting developers to try to accept that change, then there's some I think kind of like base expectations that we have to set. If a recipe is going to make a change, it has to be 100% accurate, because otherwise, a developer is just going to reject the change, and we're going to lose trust in the product, and we're not going to accept the next change that's produced automatically. A change that's produced automatically has to be style preserving. So the famous tabs and indents war that's been going on for decades, to this. We just have to, when we make a change, respect the style of the original project, so that the code that we're suggesting looks idiomatically consistent in the context of the project it's being suggested in. I think that's really important. And so this 100% accurate style preserving leads to a particular way in which we develop OpenRewrite. And we're going to develop a recipe here in a little bit, and I hope it really kind of shines through this principle. We have this principle called do no harm, that a recipe is going to make as much change as it possibly can reliably. And maybe we solve 90% of the use cases, and we leave the code in a compilable state, and that stuff and we can commit that, and we can make progress. And maybe that remaining 10% or the remaining 1% is really a diminishing return with respect to automation. Maybe let's just leave this stuff to be done manually. But the point is for us to make progress, and to make progress at an accelerated rate. So if you have to make 100% accurate changes, it means that the core refactoring engine has to be very smart. We're going to be doing abstract syntax tree manipulation, but the syntax, such as you see on the left, this tree of syntax isn't enough, because if I see a method called, say, add, I don't know whether that add method came from Java util list or if it came from some other type entirely. So if I'm going to accurately make changes, I need to be able to be sure that the syntax node that I see of a method called add corresponds to a type that I'm actually looking for. And so OpenRewrite's abstract syntax tree contains not only the syntax of the code, but also the compiler's full type attribution, around the code. So it understands everything that, the compiler knows about a particular piece of syntax. And it also goes back and scoops up the formatting of the original code, so that when we print the abstract syntax tree back out to code, it preserves the original format of it. And we can use that formatting to make changes that also look idiomatically consistent. So these are really interesting and I think unique characteristics of this project that, again, we'll see here in a little bit. The end result is really an abstract syntax tree that's incredibly information dense. We're talking millions and tens of millions of vertices in a graph for a single source file that you might see. And we put years of work into how we referentially deduplicate that and keep it compact in memory and allow us to actually do these things at real scale. So excited to show. The alternative to this, if we say suppose we don't, right? The alternative to this is really just manual work. And I think that's what we're faced with today. We work with one team that has SonarQube, and we just looked at the top 10 SonarQube issues, the top 10 critical security issues that SonarQube is reporting, and it provided an estimate of the manual time it would take to fix those issues. And in this organization, it said 4.9 years of work. It's almost laughable, right? It honestly, what winds up happening is we just silence those alarms, right? And say, we accept the current state and let's try not to add to it. But that leaves our code in a vulnerable state. It leaves it, kind of lagging behind. So with this group, we had gone and developed those 10 recipes, open sourced them. That reduced that pile of work to 4 days, ultimately. And I think that's the promise of this kind of automation. When you're dealing with, as a lot of organizations, you're dealing with tens or hundreds of millions of lines of code. The benefit here of doing the work of writing a recipe can really be an outsized effort. And so, one last thing I think I would say about the framework. OpenRewrite is Apache licensed and always will be. And the reason why we do that is really because we feel like it should be the framework author's responsibility. So when the Spring team makes a breaking change, when the JUnit team makes a breaking change, when the Kubernetes team makes a breaking change, we feel like it should be their responsibility to provide a recipe that fixes all the downstream users. You can have one Spring team developer make a change and 5 million developers downstream of them are impacted. We would like to see a world in which they're responsible, that this becomes a discipline, that they're responsible for providing that recipe. So every recipe is written is open source for that reason and always will be. I'd like to flip over now to just kind of show some of the things that we can do with this technology. And I'm going to start from Moderne. And like I said, Moderne, right now we're running this platform, which is just public.moderne.io. And this platform, we've been ingesting hundreds of millions of lines of open source code every day. Every day we produce a new AST and we run this for free, and you just log in with GitHub. And it allows you to run recipes on open source stuff. So here I've ran a recipe called Common Static Analysis Issues, which is actually just a pile of SonarQube rules basically, but that have been re-implemented as OpenRewrite recipes. And we can run these things on a selection of open source code. And the idea is that that recipe then goes and makes the change everywhere. It's removing these kind of like unused, unnecessary initializers and inserting braces. That was like the thing that you wanted to do. And the idea would be here that, again, rather than just reporting that this is a violation and requiring the developer to go fix it, OpenRewrite's already made the change. It's already suggested the change. It gets printed as a git diff. And if I'm a developer on this project, I can just commit it from here. I can just, just finish it, be done with it. Or I can go, and kind of select all of these all at once and commit them all at once. And that's I think just this really powerful, possibility, to work with. Um, outside of like, we're going to do a recipe that does Java code, like a Java code manipulation. But I also want to show you that, there's things like upgrade Maven dependency version. So, there's outside of source code itself, we often have to, update dependencies, we update infrastructure as code, we update our GitHub Actions workflows or GitLab workflows, or our, and that's just as important as updating the code. And we want to build continue to build additional AST models for these different mechanisms to, to be able to transform them. So, in this case, we said update Jackson to the latest patch release. And I think that's a really interesting, like narrow view, right? That as Java developers, we know that if you update Jackson to, bump it to a later minor release, and the versions of Jackson wind up misaligned, there's some 2.11, there's some 2.13, it's going to break the app. But if we just update to the latest patch, like if we just stay on the same minor release, but like pick up 2.13.3, then we're likely closing CVEs, because the Jackson author has this tendency to close, go back and patch older versions of Jackson when new deserialization gadgets are disclosed. So as long as you keep on the latest patch, you fix you close the vulnerability, but you don't break the app. And so this one gets updated to 2.13, but maybe one of the others gets updated to, I don't know, some totally different version. Like this one was on 2.8, so it gets pulled to 2.8.11. So these kinds of things are just really like interesting, ways of safely updating the dependencies, closing the vulnerability, but not breaking the actual application code. So that's, anyway, this platform is always out there. We're going to jump, because I love to do actual, coding here, right? And to show you what it looks like to craft a new recipe. And, then maybe we'll hop back over here and run some other things. But I want to give you a sense of what it's like to write one of these transformations. So to do that, I just went to the backlog this morning and looked for a recipe that was requested by somebody from the community, and let's just develop that. And so, like any good cooking show here, I've kind of pre-filled a few details, but we're going to write most of it here as we talk, and hopefully give you an idea of what some of the experience is like. So let's get into it. Yeah. So like any good, I guess I'll be a good test-driven development person here and say, let's write a test before we even start looking at what the code looks like. And for that, we're going to write this recipe in Java, and we have a test harness called rewrite test. And it provides these facilities to actually write example code here, which will, illustrate the thing that we're trying to transform. So I'm going to look at like, this is like, maybe some, I'm going to define what the code should look like before and after the transformation. And so before, let's say it should look like, something like this, where I've got it's all formatted. So here we're going to use a stack. And, stack is one of those classes in Java where it's, it obviously corresponds to basic data structure of stack. It's super old. At some point, the Java language authors actually built a better implementation called ArrayDQ, which has all the same, method signatures, the same behavior as stack, but is better implemented. And, so if you actually look at the Java doc for stack, it'll say, don't use stack, use ArrayDQ instead. And yet we're kind of out there, a lot of us are still using array stack because it's the more obvious name. This may be something that we don't know. So what's cool about this test harness here is I'm actually writing the before code and the after code. So the before the transformation and after the transformation. And, I'm writing it in a multi-line string, and the IDE can actually syntax highlight the code inside of the multi-line string by virtue of the fact that we have a language annotation on this method. And it actually helps you write the code inside the multi-line string. So we get to write, example code here that demonstrates the problem and demonstrates the fix. So right now we see a stack being instantiated, and afterwards we want to see, the use of an array DQ. But I've also pre-written one other test here, which is like to try to exhibit this or show this characteristic that we want to do no harm. Is what if a method returned a stack? I could change this. I could change this to a DQ, but if this is a library that's then used, in many other places, then they assign the result of that method call to a stack, then that would break. So because these things are not, they're not, even though they share the same method signature, they're not castable to one another, not assignable to one another. So we want to just, ideally, we would replace all uses of stack, but like we could just try to go about the smaller problem of replacing, the usages of stack that are kind of bounded to a particular method declaration. And so that would be safe to replace. And in that way, we just take care of some part of the problem, and move ourselves forward. And maybe along the way, we teach developers, by example, that this is really the data structure that we want folks to use. So as we develop our recipe, we're going to be trying to find a way to say, let's look for creations of stack, but ensure that they don't wind up being returned either at the end. And so this will, I think, demonstrate some other interesting capabilities. So let's go over maybe to the recipe now and look at what that looks like. So here we've just got a class which extends recipe, and it's got a display name, it's got a description of what it does. These both wind up getting rendered. It's actually marked down. So in many different places where rewrite recipes will run, whether in build tooling or in the Moderne platform, that actually gets rendered, as markdown to make it, really easily readable to folks that might want to consume that recipe. And then ultimately you've got some visitor. And so we're going to use the visitor pattern, which is basically an event-driven mechanism to kind of, narrow down or target particular parts of the abstract syntax tree that we might be interested in. So if we're going to implement this visitor and go back to the test for a moment here, what I'm really looking for first is variable declarations. I'm looking for these sort of creations of stack, or rather this one here, looking for the creation of stack, and I'm going to try to identify these and do something about it. So not surprisingly, there's a visit variable declarations method here. And this will be the starting point. This will be the place we want to hook into. And we're going to have to test whether this particular variable declaration is of the type that we're interested in. And so let's see, and maybe let's kind of narrow it even further, because this could get really complicated if we say we support this idea of creating a stack, and then a bunch of other things happen, and then we assign it to something else. So like, again, to say do no harm and to keep the recipe somewhat simpler, let's just say we're only looking for, creations of variables that immediately have an initializer after them. And so we'll say if v.getInitializer, actually, let's go one little down. We're going to look at a particular variable inside of a variable declaration. So this is one of these situations where you could have actually like int and m, right? You can declare two variables at once. And this visit variable declarations represents this whole statement right here. But what we're going to do first is like just visit just the n equals 0. And so visit variable is that lower level construct right there. So let's extract this one. And so here we're saying, like, if it's got it's got, an initializer, then maybe we're going to do something to it. So, one of the things to note right away is what I love about these recipes is that it's not a query language. It's not like a SQL, like try to identify this, replace it with that. It's not declarative. It gives you some shortcuts, we'll see in a moment, but it gives you the full expressive power of a language. So, it's a lot of recipes are very different from one another. And here we can kind of do whatever we can do in code, which really opens the door to a lot of, to solving a lot of really unique cases. So, one of the things about rewrite is we like having this, we're building up these building blocks. This recipe is something I could use in another recipe. And there's a lot of building blocks that kind of already exist to do common things. Like we're going to say, there's a change type already. And change type is smart. It knows how to, replace a fully qualified name with another fully qualified name, or just like the imported name with an imported name. And it's all the like little edge cases that go into what it means to replace one with another are kind of already captured here in this base building block. And then we can leverage it elsewhere. And so here we're just going to say, I want to replace stack with array DQ. I don't really care about the definition here. And I'm going to get the visitor off of this other recipe. And I'm going to just visit just this tree, this variable that I'm looking at right now. And and this allows me to just like narrowly apply this change type recipe to just this one variable that I'm looking at right now. And, there it is. So it's kind of like I'm going to be able to cast this here. Now this may or may not have changed because, this variable could be a string. It could be, it could be anything. But this change type will only change the tree if it's actually a stack. So, pretty basic here. So we could say, at this point, let's just run this. We've just done one little piece of it. And so let's just run this test and see what happens if we just do this piece. Let's let it build. And so one thing I love here is this assertion is actually, you can just hit Command D here and it just shows you the before after diff of the text. So it's really easy to determine whether it's doing the thing you want it to do. So I was expecting that, DQ would be replaced here, that, that array DQ, or stack would be replaced with array DQ here. Actually, this test is a bit not what I wanted. Let's turn this to void. And so it looks like this one. This one's void. This one's void now. Let's run that one more time. Copy and pasted the wrong thing. A little cleaner. Yeah, so, looks like we, had a problem. I did not replace the stack like I expected to. So what did I do wrong? Let's see. We've got stack. We've got live coding. It's always great. Oh, it looks like I didn't even get in here. Let's see. Oh, in the test, I did not say what recipe I wanted to run. So here, here I can, on the test, say I want to run new replace stack with DQ. So this kind of says for all the tests that follow here, this is what I'm trying to assert. So that's kind of like a basic thing I forgot there to add. So we'll run this again. There we go. Now we're hitting it. So yeah, we've done the first part, right? We've replaced the right side of this expression. We just replaced that initializer with an array DQ, but we still have to get this other side now too. So, since, like I said, we were dealing with, like, suppose we had the int n equals 0 m situation here. I was only looking at this part. So I didn't get a chance to see this int yet. That int is at this higher level variable declarations. And so we have this ability actually to pass messages back up the stack. So if the control is I've kind of visited down this lower level, and now that we're gonna like go back up to the higher level after this returns, and I can put a message back up on it and say, put a message on the first and closing variable declaration, and say, replace, like, go ahead and replace me now. And here, once I reach back up to this variable declaration, I can look at the cursor and I can say, replace, and the default I'm going to say is false. And I can do basically the same thing here I did below, but we're going to replace it with a different type. So here, I'm going to replace stack with this DQ. Let's run this one more time. So we're getting closer. Now I've got these, like, I've got DQ over here. I've got array DQ on the right side. But, I also need to add a couple imports. So I could say maybe add import on DQ and array DQ. And of course, those will only get added if this actually changes. And that's kind of what the maybe means here, is it's like, if this didn't make any change, I'm not going to add imports unnecessarily. I'm going to do no harm. And so we've got the imports up there now, and that's looking better. So what's left in this test here? I think I just had the wrong space character there. And this one passes. So, that's kind of what it took. It took like, 5 or 10 minutes as I bumbled through it here to do this thing that I was interested in, this kind of narrow thing that I was interested in. But remember, we've got this other test down here, like do not replace if returned. And this one's a little more complicated, right? Like how do I detect whether this variable winds up getting returned at the end of the day, potentially getting assigned to other things that eventually return. And so if I look at this right now, you'll see that I'm still transforming this stack to a DQ, and then I try to return it. Well, this code wouldn't compile, right? Because it's not the same type. It can't be coerced into that. So we've got a little bit more to do, a little bit more sophistication to add right here to see, is this something I really want to do? And so this is going to get into something we call data flow analysis or local flow analysis. We want to look around the body of this method and see how this thing is used. And for this, I just want to show you, one form of data flow. So we've got this other base building block recipe called find methods, which allows me to define like a receiver type, and in this case, I want to find constructors with any number of arguments. And I want to describe the data flow. And I'm going to run this test here. And right now I've asserted that it doesn't change anything. So it is going to find some data flow. And I just want to show you what the diff looks like, so you get a sense of how we're able to track the use of this variable through the remainder of the method. So here you see, we found the stack. This is the method I was looking for that I put in the find methods, and we're able to follow its use. We add something, oh, and it gets returned. So this is going to be the crux of what we're going to use. We're going to say, I'm going to use this ability to follow the use of a variable to then look whether that variable winds up being enclosed in a return statement. So we're going to disable this guy again, because this is kind of an example. And we have this thing called local flow spec here for any expression. And I'm going to say, I'm going to try to define what it means to determine whether this variable was returned ultimately. So there's always a assertion we can make about the source and an assertion we can make about the sink. And so see these like inputs and outputs as the variable, as the like data flows through the method. It's, really complicated way that we determine sources and sinks, but you don't really need to worry about that. The source, we're looking for things like this stack, and the sink, we're looking for whether it's part of a return. And I'm not just looking for any stack, I'm actually looking for this variable, this particular variable, the one that I'm looking at right now that I'm considering replacing. So for source, it's simple enough to just say, like, what if the initializer is this expression that I'm looking at? Like, if the initializer of this name variable, this is the name variable, stack equals new stack, if the initializer of it is this, is the kind of source, and then I want to see whether this source gets returned ultimately. And so the sink side of this is just to say, and so cursors are actually just kind of like a stack of all of the AST elements that goes to this point. So if I look at this word stack down here, its cursor parent, if you just go up one level, is the return statement. And its cursor parent is the block. And its current cursor parent is the method declaration. And it's the class, and then the whole file. So it's just a way of telescoping your way out, looking at what the, where I came from. And so I'll say if the first enclosing, if there's any enclosing return, where it's like if this is not null, then I've returned something. And that's it. So this is what it means to say, is this the right side of this expression returned? And now we need to use it. So already I have a guard here around the initializer being non-null. I can use this utility called find local flow paths and say, none of these things can match. At the place where I am right now, none of these things can match. And otherwise, I'm not going to replace it, which means this cursor message doesn't get placed, which means this doesn't happen. So that is the guard that'll prevent this theoretically from happening. Oh, that's the data flow test again. Let's go to the one, the do not replace if returned. And that works now. So that's what it took. That's what it's like to write a recipe. Just kind of getting through a little bit of these these concepts, the local flow, the ability to visit different parts of the AST. There's all sorts of information about the types on those ASTs. There's a templating mechanism, all sorts of goodies involved here, and a lot of examples. I'd like to do the same recipe. So I wrote this earlier, and I actually deployed it out to the platform so that it could be ran. And let's go to to kind of this. We put it in the cleanup package, so I could go here to this through this catalog to the cleanup package, and somewhere here there's a the stack, replace stack util.dq, and I could select a set of open source code here. Maybe let's select maybe like the entire Jenkins organization. And so this is 1,000 repositories, and say let's just run it on all 1,000 of them. And so again, you can see how quickly this goes, right? We've already searched 180,000 files. Already finding 20 repositories to change. I'm able to get in here and see, the change that was made, right here. If I go to this code originally, you'll see that, yeah, we're in a variable, we're in a method. We defined a stack. It's kind of local to this method right here. doesn't get returned. So this is exactly the kind of scenario that we said we could solve right here. That's that's the sort of principle of like do no harm, right? Let's define a narrow thing that solves all of these problems. I've at least gotten, just with 10 minutes here kind of work, I've gotten 31 repositories changed. We continue to run here. I can just commit all of these, and that's the experience that we're really after. I'd like to open it up now because there's so many ways I think this conversation could go. Obviously, this is a very different mechanism, right, than like the typical security scanner or code quality tool that just reports things, and leaves it to developers to fix. Just would love to hear your initial thoughts, and feel free to unmute.
Yeah, we'll leave the line open. If you're shy or someplace you can't unmute, we do have the Q&A chat open and the general chat.
Yeah. Hey, Jim. Hey, Jonathan. Can you hear me?
Yeah.
Yep.
All right. I posted this earlier. When you were showing me, the CVE updates, I was just curious on something like that, as opposed to doing that, just that blind search and replace, look for this, look for that, replace it. Would the ability to go out and hit any one of the CVE, OWASP, wherever you're going to go get your vulnerabilities from, and then go filter down to the resolution and what that resolution is, right? Which is typically upgrade libraries and things like that. To me, this is perfect. There's a perfect option for that, right? Because it can say, okay, I'm going from this library to that library. Now, what it doesn't necessarily tell us is while we are fixing the CVE threat, we could be breaking code somewhere else because, we never know how it's used, right? But we have at least gone through that first portion to test the build. And then if our developers took the approach you took, which was TDD, which most don't, when they ran it, they would actually see, oh, I broke some tests. So now let me go look at what I have, right?
Right.
But I like the way that that it has the ability to do that. And then I'm assuming that in that recipe, you could basically say, go out and, prep
this data source, or you have CVE
vulnerability and replacement stuff in a spreadsheet somewhere. And it would say, if I find it, then go replace it with this, and then show me all the changes I'm going to make.
That's right. I think it is like using. I think we're complementary to a lot of these scanners, right? Like use that scanner to inform what the most significant things are that you should do today. That you could, and that's what I kind of alluded to. There's this organization. It's a top 10, 4.9 years of work. Let's see if we can get those top 10 done. And there's going to be 100 behind them, but let's just see if we can get 10 done. And then that's that's a start. And I agree that like there's always a potential, even in this do no harm, ethos, that a recipe does the wrong thing. And we consider that a bug. I consider that a bug in the recipe. The recipe should be bounded in such a way that it never makes a breaking change. But ultimately, the result of a recipe is presented to a developer who then reviews and accepts that change, just as if somebody made it manually. So it kind of passes through the normal software delivery life cycle accepted by somebody, on the team. And, when you commit through, say, like the Moderne platform, the author on the commit is actually that developer that's logged in. It's like, their name is on it. It's not like a bot that operates on the side and just randomly permutes the code. And I think that's really important. It's a tool that's making the developer much more efficient at going and stamping it out everywhere.
Right.
Yeah, really good.
Yeah, and keep in mind that a recipe is meant for deviation. You can change the ingredients and have a different outcome, and someone can be like, wow, this caused me to discover something that I did not know, and now the end product is better than I ever expected.
Yeah. I want to show another. I should have shown this earlier. I kind of forgot, honestly. I'll show an example of something that I think shows just like how tedious this stuff can be. This is JUnit 4 to 5 transformation. This is what a recipe did to move JUnit 4 to 5 for Spring Cloud Dataflow a while back. And note that the Dataflow team had been working on this. We leave this PR open just for this purpose, but like they had been working on this for 18 months. You know, thousands and thousands of tests. And there was a point where if you didn't go from JUnit 4 to 5, you can't migrate from Spring Boot 2 to 3 to 2.4. Spring Boot 2 to 3 is retired, and now, you know, you're in trouble, basically. You know, so, you know, but to go through, what it means is to say every org JUnit before has to be an org JUnit Jupyter API before each now, you know, because they changed the name. And so I got to change all those imports. I have to go replace all the annotations. Note that this is a style, right? This could have been org JUnit star, and now like I have to understand whether I'm star unfolding and unfolding, and what was the star folding level of this project, and where do the static imports go after or before, or like, so these are all elements of trying to preserve the style of the original project. And then, you know, some annotations just get removed altogether, and some of them, you know, they used to be able to define an exception here on the test method, but now you have to use assert throws and put the exception down here and the rest of the method body in a lambda. And note that there's another stylistic thing here. Did I use tabs here? In which case I want to use tabs down here. Did I use spaces? Do I put spaces before the parentheses? You know, so all these kind of, and then you just have to do this like thousands of times over again. And this is the kind of stuff, interestingly, it winds up usually being the most senior developers that wind up doing this work, because they kind of know where all the problem areas are. They're kind of the most, and so you've got the most experienced people doing the most menial work, unfortunately, in many cases. And so it's really about kind of like freeing them to do something else that's of more value and more interesting. And to kind of illustrate how these recipes stack, because, you know, we saw an example there of how we were using change type inside of that recipe we just developed. But if I went to say like this JUnit thing here, this whoops.
So did you create a log4j recipe?
Yep.
Save the world.
Yeah, exactly. I mean, any of these things, right? They just have that. So you could see like JUnit Jupyter from JUnit 4 is actually a recipe that's composed of using the wire mock extension, changing some of the base building blocks like change type, assumed assumptions, reorder these arguments, add and remove dependencies from Maven, you know, migrate from Mockito 1 to Mockito 3, you know, which is a whole nother set of recipes. So they can kind of like, it's just very much like a, you know, a rule-based system, and they just build and build and build and build on each other the larger the ecosystem expands. So that's what I mean. It kind of, if each open source framework author accepts responsibility at their level, then it makes the whole much more achievable for everyone.
Very cool.
Yeah.
Well, thanks for doing all the work and everybody involved, because that's pretty I would say takes a lot of time, right? A lot of effort.
Yep.
And you're staring at that stuff every day. So
Yep.
knowing what I really liked was that you left something out, and then you had to look at it from that further approach that we always have a hard time looking at, to say, oh, hey, I gotta add this. I forgot this one little simple thing, right? A semicolon here or a comma. I mean, what am I doing, right? But you look at it and, okay, this worked. This is what I did. So, so kudos to the whole entire team. This is really awesome.
Yep. Thank you. Very good.
It just proves we're human, right?
For sure. Yeah, and humanness always comes out in live demos, right?
Exactly. Yeah. I'm sure Jim never has that problem, but you know.
Yeah, that's right.
Perfect people do.
That's right. Yeah. Well, what other thoughts are there out there? You know.
Nothing, huh? I was going to mention, Jonathan, something that I think is kind of like deceiving is the semantic awareness we have in Maven builds. Like when you say upgrade a dependency in Maven, if you've ever had to do that by hand, is it in a property? Is it in a managed dependency? The framework is semantically aware of Maven, so we've built parsers on top of that. So it can do some very sophisticated and surprising things that you would think would be almost magical. Specifically with like upgrading the dependency. So like somebody mentioned CVEs. That's something that is, where this really shines.
Yeah, and that's actually a skill that's fairly rare in any organization, is like knowing how to update a dependency right. There's a lot of wrong ways to do it, but there's a lot of rules to that to that system for sure.
Well, the fact that we still have to deal with 4 spaces versus a tab, or 2 spaces versus a tab. I mean, the fact that you have to consider that in everything tells us how far we've progressed in development, yet how far we haven't.
One of the things I love about working on just hundreds of millions of lines of code is just seeing the crazy variations out there that you wouldn't expect. I saw a pile of code one time whose indentation format was 2 tabs and 3 spaces per indentation level. I'm not sure why. I don't know if it was a joke, but this file was just, sure enough, like reliably 2 tab, 3 space, 2 tab, 3 space.
That was a cut and paste from Stack Overflow or something, probably.
Yeah.
Formatting that never got fixed.
And so, yeah, it really can stretch the the detection algorithm a lot, in ways that you don't anticipate. Very early in its life cycle, I would take the entire Netflix code base and pull it in and then print it back out. And if there was any change, then there was something wrong with the framework. But I got to see all sorts of crazy variation I would not have imagined, initially. So, and now we're just doing that on a good chunk of GitHub. But so very cool.
All right. If you have questions, we do have the chat open, or you can just grab the mic.
Yeah, please do.
I have a question. So we showed Java here. Are there any other languages that are supported?
Yeah, it's right now. We started in Java, but it's Terraform, which is HCL, YAML, properties, XML. So a lot of infrastructure as code type things are already are there. And like Tyler mentioned, sometimes we have semantic models built on top of the base. So for XML, there's Maven built on top of XML, Kubernetes on top of YAML, GitHub Actions on top of YAML. But what we have to do, I think about 90+% of the NIST suite of COBOL now passes, and a parser we have for that. We have to build TypeScript, Python, and C# this year, and that sounds like a tall order. What's really interesting, we discovered a few months ago, is that maybe this isn't surprising, but the things like JavaScript and Java actually share basically the same AST model. Really, they look very different in text, but their AST model is basically the same, and the way we print them back out is different. And what's great about that is we get to do these mappings from the compiler's representation of the AST to this basically the same model for Java, TypeScript, Python, C#, which all belong to the same island grammar of self-similar languages. And some of the base building blocks like change method name, change type, these sort of things that worked once for Java just work automatically in Python. Obviously, you wouldn't be doing org JUnit before on Python, but the same base building block works. And similarly, we added Groovy support a while back and did a little work on Kotlin as well. And even though Groovy, Java, and Kotlin look very different, they all share the same AST model. So when we write the recipe we just wrote right now for Stack would just automatically work on Groovy and Kotlin as well, without having to rewrite it, 3 times for 3 different JVM languages. So that's really kind of an interesting world. From the platform perspective, we wrote this like Moderne platform in Java as well. Again, that's where a lot of our experiences. And it was kind of lucky because Grail VM these days supports a lot of interoperability between languages. And when we started exploring TypeScript as a language, actually have a nascent mechanism where you can write the TypeScript recipe in TypeScript so that it's a native language experience for that, that language community, but it still runs on the same infrastructure. And I think that's going to be really, really important going forward, is that there's a shared infrastructure level for all of these languages. So I'd say in the next, 2-3 quarters, we have to be done with Python, TypeScript, and C#.
Golang is anywhere in your radar?
Golang is less so. Like I would say, it'll come, but it's not quite as prevalent in the large enterprise code bases that we work with right now. And it's growing and it'll get there. But we try to focus on the things that are most painful right now to people.
So .NET Core.
Exactly. Yep. So think the big, like the real painful things right now: Python 2 to 3, .NET Core migration. Like these still have significant lifts to do.
Macromedia Flash. Don't forget about that.
Yeah, exactly.
Hey, I'm just saying that because there's probably people out there who don't have a clue what that is.
Oh. Yeah, I remember.
Yeah, I was particularly interested about the Golang because the company I work with now, they have a lot of things in Go.
Yeah, I think it's understandable. Yeah, it'll come. It's a, and sometimes the roadmap gets shuffled around too. But yeah, a lot to do. I think Java, we built Java early. That was interestingly, that was about 39, I think, AST elements or something in its language. Then we went to undertake COBOL that had 650 or something AST model elements. It was like, what did we get into? And so, there was some automation developed. There's some additional tooling developed to help us accelerate language development because there was 20 times the AST elements in that language than there was in Java. So I think that'll help add new languages.
So question, why was COBOL picked over any next one?
Well, to be honest, it's a practical argument. It's less about what's next and it's more about what is. And, there's huge enterprise code bases, which involve a lot of that. And you saw kind of with this, there's a real search component here. You saw find method usages. You saw how we just did local data flow. That local data flow expands pretty soon into global data flow. Imagine being able to track data going from kind of like UI down through into a COBOL procedure down, down below. And so those are big pain points, trying to even study the impact surface area of a piece of data flowing through a system. And, so it's purpose driven in that way. There's also there's a bit of a timely element to that. IBM has been trying to retire COBOL 4 for a while. They don't really have a mechanism to migrate. So we're looking at they're thinking about contributing parser technology and like how can they help their customers move forward. And I like that.
That makes sense.
Yeah. But yeah, super interesting.
And I'll jump in with one, a non-technical question that I like to ask all of our speakers. So if you could jump back in time. First, you have to invent a time machine. But if you could go back in time and talk to early Jonathan, what kind of career advice would you give yourself, knowing what you know now?
What kind of career advice would you give yourself? I'll think for a moment here.
Oh man, bouncing it back.
What's in your bag?
I mean, that even though your technical skills are good, and a lot of technical people are introverts, to you get to know your fellow humans, what they're good at, because it ends up being a team sport. So if you know where you can go to get things done, it'll help get you there. And if you can work with lots of people, regardless of their of their nature or whatever, it can help take you places. So even though if you're introverted and like to focus on the technology, reach out, get in touch with others, and it should help a lot.
Yeah, I like that a lot. I think, in my case, I started in a small insurance company. That was kind of my first job for a while. Bounced back and forth between the Army and this insurance company for a number of years. And then, one day out of the blue, I get a recruiting email from Facebook. I got real excited, did the interview, failed terribly at it. Really badly, in spite of the fact that I kind of studied as much as I could. Kind of was really, down, right? Like I was like, well, guess don't cut it there. And about a year later, got a call randomly from Netflix. Did real well in that interview. They gave me a take-home problem. I did the problem, but it was kind of open-ended. So I worked through the weekend and said, I'm just gonna keep building on this until you tell me to stop. So by Sunday they were like, okay, stop. We're like gone beyond the problem. And so I think that ultimately went there. And I think I got that really opened a lot of doors to go there. But looking back, I think I've seen that every organization we've ever worked with, whether it be the small insurance company, big retailer, bank, there are a core of really good developers everywhere. And so, yeah, I mean, you probably can go further than you think. So it's and they'd be lucky to have you if you're one of those people in one of those organizations. So, yeah.
All right. We'll leave the mic and chat open for a little bit longer. We'll maybe if there's one more question hiding out there, let's see.
I like that. Don't become a developer. Once you experience it, there's no going back. That's right. I hope that's mostly positive. So yeah, I agree. I think development is engineering, software engineering is kind of an art. At least I like the artistic element of it, and I don't want to do the JNet 4 to 5 conversion anymore. So that's why I'm doing what I'm doing now. But I'd like to get back to the creative aspect of it, because it really is a creative discipline. Yeah.
All right, seeing no questions coming in on the chat and the mic activity dropping down, we'll close out the Q&A section and give our appreciation to Jonathan. Thanks for taking time to show us this great technology that you've been working on. Hopefully, it will save us 4 years and 9 months of developer time, at least minimum. Appreciate it. Thank you for coming out.